What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 10, Section 5, Polar Form of Complex Numbers. Let's do it. Question number 1 asks, a complex number is a plus bi. Explain each part. So when we talk about a complex number, we got two components. We've got the real part and the imaginary part, right? So a is considered the real part. So an example would be like 3 plus 2i. And this is just a real number. And then the imaginary part contains I. And if you remember, I is actually the square root of -1. The reason why we say the square root of -1 is an imaginary number is because you can't take the square root of a negative, right? -1 times itself is +1. +1 times itself is 1. So there's no real number that we can think of that when you multiply it against itself, we get -1. Hence, we create this number I, an imaginary number. So anyways, that's how you do it. Done. Number 3, how is a complex number converted to polar form? So the way we do that is as follows. So we're going to use this equation, x equals r cosine theta and y equals r sine theta, which we've seen in a previous section. So that's how you do it. Done. What is De Moivre's theorem and what is it used for? So first let me write out the formula. And what this is used for is, let's say z is a complex number and we're raising it to a certain power. We can use this formula to evaluate it. So for example, if I knew that z was equal to the following complex number, if I wanted to know, hey, what's z to the 3rd power, to the 4th power, I would just plug this entire piece into this formula, and then I'd raise this to that nth power and so on and so forth. Take that and multiply by the theta value and so on. So that's how you use it. Boom, done. So for this one, to find the absolute value, we use the following formula where we square the real and the imaginary, add them together, and then take the square root. So -7 squared is 49. I squared is -1. So we add those together. 49 plus -1 is 48. And then we can simplify the radical of 48 because square root of 48 is really 3 times 16. And this is great because I can take the square root of 16, which is 4, and bring it outside, which gives us 4 rad 3, boom, done. So for this one, to find the absolute value, what we're going to do is we're going to take the square root of the a value squared, so that's -7 squared, plus the b value, the coefficient in front of I, which is simply 1 squared. So that's the square root of 49 plus 1, which is 50. And then we can simplify 50, right? 50 is really 2 times 25. 25 is a nice perfect square. Square root of that is 5 when we bring it outside. And our final answer is 5 rad 2, boom, done. For this one, to find the absolute value, we take the square root of a squared plus b squared, right? That's the a value, and the imaginary coefficient is the b value. So we got the square root of radical 2 squared, which is just 2, and then we got that -6 squared, which is 36. So we add those together, and we got the square root of 38. Now, there's no perfect squares in 38 because the best I can break it down to in terms of prime factors are 2 and 19. Neither of those are perfect squares, so we leave it as is, boom, done. For this one, to find the absolute value, we take the square root of the real part squared plus the square root of the imaginary part squared. So we got 2.2 squared plus 3.1. Technically, it's -3.1, but it's going to be squared, so it doesn't matter. So then here is 2.2 squared. Here is I'm putting the negative, but it doesn't really matter. 3.1 squared. So we got 4.84, 9.61. 4.84 plus 9.61. And that is 14.45. That's how you do it. Done. So for this one, we're going to write it in polar form. So the first thing I'm going to do is I'm going to figure out my r value. And the r value can be figured out by taking the square root of, again, x squared plus y squared. All right, so we got 8 squared plus, and then we could say -4 squared, and that's 64 plus 16, which is the square root of 80. So we can simplify that a little bit because I know that 80 is 5 times 16, square root of 16 is 4. So we got 4 rad 5. And so now we could say the final form would be 4 rad 5 cosine theta plus I sine theta. Now we need to figure out the theta value. We can do that using the formula x equals r cosine theta, for example, right? And in this case, our x value is 8, and we already know r is 4 rad 5. So now we can use this to find cosine of theta. So what I'm going to do is I'm going to divide by 4 rad 5, and then I'm going to take arc cosine of this argument to isolate the theta. So then theta equals arc cosine, we take arc cosine to both sides, but arc cosine like this. So let's plug it into Desmos and see what that is in degrees. And then we get a value of 26.56 degrees. But again, this is in the first quadrant. Now, when we look back at this, you notice that the x value is positive, but the y value is negative. And we have to pay attention to that, because if the y value is negative, that would fit into this equation, r sine of theta. So you want to think about that for a second, because that means that cosine is providing a positive value, but sine is actually giving a negative value. So the only quadrant where sine is negative and cosine is positive is in the fourth quadrant. So we have to find an angle in the fourth quadrant with this reference angle. And to do that, all I got to do is I got to subtract this from 360. So we go like this, and there we get 333.43. So therefore we can rewrite this. And in the back of the book, they use this nice little shorthand. Instead of cosine theta plus I sine theta, they just say CIS. Okay, and that kind of represents that. And then the theta value can go in here. And rounding to the nearest tenth, it'd be 333.4. That's how you do it. Done. So for this one, the first thing we want to notice is that both the x and the y are positive. And that's essentially like thinking about, hey, if we're talking about the unit circle, where are x and y both positive, or sine and cosine both positive? Quadrant 1. So we already know we're in quadrant 1, so that's helpful. All right, now we're going to continue. First, we need to find the r value, and so the r value is going to equal the square root of the x squared, which is rad 3 squared, plus that coefficient in front of the I, the y squared, 1 squared, and that would be 3 plus 1 is 4, square root of 4 is 2. So r is 2. And now using one of our formulas, x equals r cosine theta, to solve for theta, since the x is rad 3 equals the radius 2 times cosine of theta. Now we can solve for theta, isolating like so. Then I got to take arc cosine. Now you might recognize rad 3 over 2. It's in the unit circle. So arc cosine of rad 3 over 2 is 30 degrees, or in radians, which is how they present it in the back of the book, that's pi over 6. And we know that's good because we're trying to find something in the first quadrant, that's in the first quadrant. Hence, our final answer is 2, and then this nice little abbreviation, pi 6, boom, done. So for this one, we're going from polar to rectangular, so let's do that now. Of course, we have an r value of 7, so that would mean our x value is 7 cosine of theta, and we know that theta is pi over 6, and our y value is 7 times sine of pi over 6. Okay, let's evaluate that. So cosine of pi 6, that's rad 3 over 2, so x is 7 rad 3 over 2. Sine of pi 6 is 1/2, so y is 7 times 1/2, which is 7/2. And now we can finish off the complex form. It's the x value, 7 rad 3 over 2, plus the y value times I. That's how you do it. Done. So for this one, we know we have an r value of 4, and we got that theta value, 7 pi 6. So let's first get the x and the y. So the x is r, which is 4, and then it's cosine of that theta value, 7 pi 6. The y is that same thing, 4, but it's sine that same theta value. Now, if you remember from the unit circle, 7 pi 6 is the same reference angle as pi 6, but we're talking about the third quadrant. So cosine of pi 6 is rad 3 over 2, but in the third quadrant, it's negative. So x equals 4 times negative rad 3 over 2. That simplifies to negative 2 rad 3. And for y, it's, sine of 7 pi 6, that's 1/2, but we're in quadrant 3, so it's negative. So negative 1/2 times 4 is negative 2. So then we're left with a final answer of negative 2 rad 3. That's the x value, minus 2, because it's negative 2 times I. That's how you do it. Done. So for this one, we got a theta of 240. We have an r of 3. So now we can find x and y. So x again equals 3 cosine of that theta. And the y is r, which is 3, and then sine of the same theta, like so. Okay, now 240, if we think about the unit circle, that's like right here, and that's got a reference angle of 60 degrees. So we're third quadrant, and we got a reference angle of 60. So what is cosine of 60? Cosine of 60 is 1/2. In the third quadrant, that's negative 1/2. So x is negative 3/2. Sine of 60 is rad 3 over 2. But again, we're in quadrant 3, so it's negative. So y equals 3 times negative red 3 over 2. So there's my y value. Now let's put it into the right format. So we got negative 3 halves the x first. And since that's a negative, I'm just going to say minus 3 red 3 over 2. And of course, that's a complex part, so that's times I. And that is how you do it. Done. For the following exercises, find z1 times z2 in polar form. So what I've done here is I already wrote down the general formula for how we're going to do this to get z1 times z2, that product. So what we do first is we multiply r1, which is this value right here, and r2, and that would be 4 rad 3. And then we take CIS of the sum of these two theta values. 116 plus 82 is 198, and that's it. That's how you do it. Boom. So for this one, we're meant to find the product, and here we multiply r1 and r2. So 3 times 1/4, that's 3/4, and then it's CIS of the sum of the theta value. So 120 plus 60 is going to give us 180. That's how you do it. Boom, done. So for this one, we're finding the product, and here's the formula for the product. So z1 times z2, first we have to multiply the two r values. That's rad 75. And then it's CIS of the sum of these two. And first, let's get common denominators. Let's make it 24. So I'm going to multiply that one by 3. We got 15 pi over 24. This one times 2, which is 2 pi over 24. So of course, you add them together, it's going to be 17 pi over 24. But before we lock this in as our final answer, we want to see if we can simplify this, which we can, because 75 is really 3 times 25. Then we can take the square root of 25, which is 5. So it's free from the radical. So our final answer is 5 rad 3 CIS 17 pi over 24. That's how you do it. Done. So for this one, to take the quotient, the way you do it is you take the quotient literally of the r value, 21 divided by 3, which is 7. And then for the degrees, for the theta value, you subtract, right? For product, you added. For quotient, we subtract. So 135 minus 65 is 70. So that's how you do it. Done. So to find the quotient, what we're going to do is we're going to take the quotient of those two r values. 15 divided by 3 is 5. And then we take the difference of these theta values. 120 minus 40 is 80 degrees. That's how you do it. Done. So for this one, to find the quotient, we take the quotient of these two. So 5 rad 2 divided by rad 2 ends up being just 5, right? The radicals essentially cancel out. And then we have to take the difference of pi and 2 pi thirds. So pi minus 2 pi thirds, we're going to get common denominators. I'm going to make that 3 pi over 3. 3 pi minus 2 pi is 1 pi over 3, so pi thirds, like so. That's how you do it. Done. For the following exercises, find the powers of each complex number in polar form. So find z to the third when z equals this. So here's the formula down here. So it's simply going to be r to the third, which is 5 to the third, which is 125, and then it's CIS. And then again, that's 3. So 3 times that 45, that's what we're doing there, multiplying it by the theta. 3 times 45 is 135. That's how you do it. Boom, done. So for this one, we're going to find z to the second power using this formula. It's going to be r to the second power, because that's n. 3 squared is, of course, n. And then CIS, and then it's that same n value, 2, times the original theta, 120. 2 times 120 is 240. That's how you do it. Done. So for this one, let's plug and chug into the formula. Now you notice there's no explicit coefficient here, but that means it's just a 1. So we take 1 to the 4th power, that's just 1, so I don't even need to write it. And then we got CIS, and then we got the original theta times that power. So 4 times 3 pi is 12 pi, so we'd have a theta of 12 pi over 16. I'm writing it here because I want to simplify it before I put it in the final answer. Divide top and bottom by 4, we got 3 pi fourths. That's how you do it. Done. So for this one, we're meant to evaluate the root, and that is going to basically be the n value, right? Because if I'm taking the cubic root, that's 1 over 3, right? Taking the 4th root is like raising to the 1 over 4 power. So cube root, that's going to be an n value of 3. So we got r 27 to the 1/3 power, CIS. And then we have our theta value divided by n. Again, n is 3. So 240 divided by 3 is 80. And then we got plus, and now this is interesting, right? Here I have this in radians, 2 pi k over n, but it's the same as 2 pi is the same as 360 k, right? So it's by multiples of 360 over 3, aka multiples of 120. So we could kind of continue this out, right? But if I'm only going to provide the solutions up to 360, we'd have the following. So 27 to the 1/3 power, aka the cube root of 27 is 3, right? 3 times 3 times 3 is 27. So we have 3 CIS. And then first we have when k is 0, we just have 80. Then we'd have another solution, 3 CIS, and we're adding by multiples of 120. Then we got 200. And then the last one again, before we hit 360 or surpass 360, I should say, is add 120 again to 200 is 320. So those are your three answers. Boom, done. So for this one, we're taking the cube root. Again, that's an n value of 3 for this. So let's plug and chug. First, we got an r value of 32. So it's 32 to the 1/3 power, aka the cube root. CIS, and then we got that theta, 2 pi thirds divided by 3, or like times 1/3 is the same way. So we could say 2 pi ninths, and then it's plus increments of 2 pi thirds, right, times k. So we're going to give everything between 0 and 2 pi. So let's do that now. First of all, what's the cube root of 32? So we want to put this in its nice, most simplified form. So let's just think about what is 32. 32 is really 8 times 4. And the reason why I like this breakdown is because 8 is a perfect cube. So the cube root of 8 is 2. So now we got a nice r value, 2 cube root of 4, CIS. And then let's give the first answer between 0 and 2 pi, where we just have 2 pi ninths, right? Where k is 0. And then let's give the additional ones. So first of all, when k is 1, that's 2 pi thirds, aka 6 pi ninths, plus this 2 pi ninths, which is 8 pi ninths. And then we have another one, 2 cube root of 4. And then adding on 6 pi ninths to this gives us 14 pi ninths. And we're going to stop there because if I did another increment, I'd go beyond 2 pi, aka 18 pi over 9. So these are the three answers between 0 and 2 pi. Done. So for this one, we're taking a square root. Square root means 2, right? That's the index. And that means that's what n equals. So let's plug and chug. So that means we have an r value of 8 to the 1/2 CIS. So my theta value is 7 pi fourths divided by 2, or 7 pi eighths. And then we got plus 2 pi k, or 2k pi, whatever, over, again, that 2 value like so. All right, so now let's do this. First of all, 8 to the 1/2, that's a square root of 8. Square root of 8, that's 2 times 4, so we can simplify that to 2 rad 2. So then we got 2 rad 2 CIS. First one, k is 0, that's just our first value, 7 pi eighths. And then when k is 1, okay, that's going to be 2 pi over 2, aka plus pi. So we're just going to add 1 pi to that, or 8 pi eighths. That's going to give us 15 pi eighths. And then, of course, everything else here is the same. And we can't go beyond that. Look, we're already so close to 2 pi, so the next value would go beyond 2 pi. So these would be the two solutions between 0 and 2 pi in radians. Done. So to plot something like this in our complex plane, the imaginary is going on the y-axis, well, would typically be the y-axis, and then the real portion right here is going this way. So we got a real value, aka an x value of -3. So we go 3 to the left, 1, 2, 3. And then we got an imaginary component of -3. So we go 3 down, 1, 2, 3, which would give us a point right here. That's how you do it. Done. So for this one, we graph the real part on this axis and the imaginary coefficient -5 on this axis going up and down. So we're literally going, starting here, we're going left 1, down 5. That's how you plot it. Done. So for this one, it looks like there is no real component. So it might be easier to write it like this, 0 plus 2i. So again, the real component is on this axis, and so it's not going anywhere, so we're staying here. And then this goes on the imaginary axis, that 2, so we go up 2 like here, and that's how you do it. Done. So for this one, the real component is 6, and the imaginary component is -2. So we go 6 out to the right on the real axis, 2 down on the imaginary, and that's how you do it. So for this one, the real component, right, is 1. The imaginary coefficient right there, component is -4. So again, we go 1 on the real axis. That's 1 to the right because it's positive. And then -4, so we go down 4 on the imaginary axis. So we're right there. Done. So for this one, we're going to start out with the formula z, that number that we're getting in polar form, is equal to r times e to the I theta. And it says use a graphing calculator, but what we're going to do is we're going to use Desmos, and we're going to kind of use the typical conversion, right? We have to find r, we have to find theta from this. So I'm going to show you how to do that now. And basically, our x is going to be that 3, our y is going to be that -2, and then on Desmos, this is going to be b and a. So let me show you what I mean. So again, to get the r value, we take the square root of a squared plus b squared, or x squared plus y squared, and I plugged in the values there. So we get 3.61 to the nearest hundredth. We've also found the theta value using this formula, which is -0.59 if we round it to the nearest hundredth radians. So let's plug it back in. And we got 3.61 e to the -0.59 I. That's how you do it. Done. So for this one, we're trying to get back to rectangular form, and we know the r value is 4, and we know the theta value is 120. And then we remember that x equals r cosine theta, and y equals r sine theta. All right, let's plug it into Desmos, and let's see what we get. So for x, we got -2. For y, we got 3.46 to the nearest hundredth. So that's -2 plus 3.46 I. Boom, done. So for this one, we got an r value of 5, and we got a theta value of 210. And remembering that x is equal to r cosine theta, and y is equal to r sine theta, we can use Desmos to calculate these values. So here we got -4.33 for x, -2.5 for y. So we got -4.33 minus 2.5 with the I. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.